What is this type 3? Type 3 is if q of x is equals to what we discussed at the starting of particular solutions. 6 types are there. In that, this is the third type, x power m, or a polynomial in functions of x, that I mentioned as p of x, polynomial in functions of x. If this is the case, then how to write our yp? As usual, yp is equals to 1 by f of d of q of x. What is q of x? Okay, for the name's sake, I'm taking p of x. That means a polynomial in functions of x. 1 by f of d of p of x form, polynomial in functions of x. That means it may be x power 2 or x power 3 or x power 20, or a polynomial in functions of x, x square plus 5x plus 1, it may be. Okay, if this is the case, then the very important point is we have to write the denominator part as 1 plus phi of t or 1 minus phi of t. How we have to write it, that we'll discuss in problem. Either 1 plus phi of t or 1 minus phi of t of p of x. Like this we have to write. After we write this, then taking the denominator part to numerator, what it's going to become? 1 plus phi of d whole power minus 1 or 1 minus phi of d whole power minus 1 of p of x. Don't assume that కలర్స్ మార్చారు సార్ మీరు ఇక్కడ, అందువలన ప్లస్ ప్లస్ గానే ఉంటుంది, మైనస్ మైనస్ గానే ఉంటుంది అంతే. నేను జస్ట్ ఫర్ అండ్ ఇఫ్ ఐడెంటిఫైయింగ్ ద ప్రాసెస్ ఐ మెన్షన్ దిస్ ఈస్ ద ఫార్ములా ఆఫ్ yp of type 3. That's enough. But this is not this is only the concept, but the concept is not clear. Only in problems you can understand clearly. Okay, so now first of all I'm going to give a note. Note contains 4 formulas. That first formula and the second formula, third formula and fourth formula. Most of the cases I'll go for first and second formulas only, not for third and fourth formulas. Yes, any of you can remember what is the formula of 1 minus x whole power minus 1? Anybody? 1 plus x square plus x cube plus x power 4 plus and so on. X power 5 power only will increases, that's enough. But same manner, tell me what is the formula of 1 plus x whole power minus 1? Same terms we'll get 1 x square x cube x power 4 and so on. But what are the coefficients we'll get? First term is plus, second term is minus, next plus, next minus, next plus, next minus, and so on. These are the cases. Alternatively, plus and minus we'll get it. So how it's look like? It's like a alternative series form. Okay, so same manner, you know that 1 minus x whole power minus 2, but rarely we will use this. 1 minus x whole power minus 2 is 1 plus 2x plus 3x square plus 4x cube plus 5x power 4 and so on. Okay, whenever and so on, put only 3 dashes, that's enough. Same manner, what is the formula of 1 plus x whole power minus 2? The terms what we got previous formula will get same, but the signs will changes alternatively. Yes or no? Okay, so plus, first term is plus, next term is minus, plus minus plus, next term will get 5x power 4 minus and so on. Okay, so these are the formulas will be useful for us. Okay, so let me take a problem, then only you can understand our case, our type. So I'm taking here solve. Okay, I'm taking our previous problem, something d square minus 4d plus 3 of y is equals to, okay, for the namesake I'm taking only x square. Okay, for the namesake I'm taking x square. So if we find the solution for this, What is the general solution? I think it is equation number 1. What is this general solution? Is y equals to yc plus yp. Writing a little bit fastly that direct steps. Yc plus yp is equation number 2. Okay, now we need to find yc. So writing the direct step, because you can observe in the previous type 2 we discussed the same. Fourth problem is same. D square minus 4d plus 3. So I mentioned as the complementary solution is c1 e power x plus c2 e power 3x. Okay, just for the name's sake, I'll just write the main direct steps. So finding yc, consider auxiliary equation f of m equals to 0. That implies m square minus 4m plus 3 equals to 0. Find out the roots, then you will get m is equals to plus 1 and plus 3, only 2 roots. Then yc will be like this. Yc equals to complementary solution, yc equals to c1 e power x plus c2 e power 3x. So you know how to find this clearly, so that I just explained the main points only. So now going to find yp. Finding yp. Finding yp. While finding yp, we have to take, as usual, 1 by f of d of q of x. Q of x. Here, yp is equals to, better I am writing sticking to the left side instead of continuing from here. So writing here, f of d is nothing but d square minus 4d plus 3. The point which I am going to tell you now is very important, students. Of q of x is x square we have taken. Okay. Now what we have to do is q of x is x square. Yes, please concentrate here onwards. This is the important step we are going to discuss. Now, denominator, what is the least power of d? What is the least power of d? Speak, unmute, and you can say. What is the least power of d? Okay, otherwise 0. So in the first term, the d power is 2. In the second term, 1. And the third term, no d. That means d power 0. Okay, so we have to take the least term common. What is the least power of d? 0. So total term we have to take common. If we take the total term common, we are going to get 3 into, okay, d square minus 4d by 3 plus 1. Am I correct? Of x square. Okay, but I'm rewriting like this, 1 by 3 into, okay, now I'm taking this one to numerator part. While I'm taking this one to numerator part, this a plus 1 can be written as 1 plus a also. So 1 plus d square minus 4d by 3. I'm putting brackets for this. Now how it looks like? How it looks like? It is a function in terms of d, like phi of d. It is in the form of 1 plus phi of d. Yes or no? But we are taking to numerator. Because of that, what we are going to get? Whole power minus 1. Now, if we observe how it looks like, this is important. So that marking with this. So it is in the form of 1 plus x whole power minus 1. What is the form of 1 plus x whole power minus 1? 1 minus x plus x square. Okay, formula number 2. 1 minus x plus x square minus x cube plus 4 x power 4 minus and so on. Sir, like this we are having infinite number of terms. How many number of terms we have to take? That is important point here. Okay, first and foremost point is we have to apply type 3. Whenever we need to apply type 3, what is the important point we have to do? We have to take the total least power of d term common. If we have plus 3, then take plus 3. If we have minus 3, here it is, take minus 3 common. Okay, that is important point here. Okay, now how many number of terms we have to get it? For that, I'm going to do a small rough work here. I'm going to find a differentiation of x square. What is the differentiation of x square? 2x. Second derivative of x square. What is the second derivative of x square? Simply 2. What is the third derivative of x square? How much? 0. 0. Fourth derivative is 0. And so on, all the derivatives will be 0. So please take it as a cutoff. So up to which derivative it is existing? Second derivative. So we need to expand this in the form of formula number 2 up to power 2. What is that? Up to power 2, like x square. So going to write it. 1 plus x whole power minus 1 formula I'm going to write here. Okay. 1 by 3 is constant. 1 by 3 into, putting brackets, 1 plus x whole power minus 1 is 1 minus x. What is x value? D square minus 4d by 3 plus x square, d square minus 4d by 3 whole square. What I mentioned, up to x square only we have to go. Why? Because of x square. Forget about it. Because of up to second derivative is existing. So we are going up to whole power 2. For example, the third derivative is existing. What we have to do? We have to take one more term. Okay. But don't take the next terms. Put and so on. Of x square. This is of x square is important. You need to write like this only. Okay. So now what we have to do is we have to simplify inside the brackets, which are in the blue color. 1 by 3 into 1 minus d square by 3 minus into minus plus 4 by 3d. I hope you people are understanding. Plus 1 by 3 square is nothing but 9 into, what is that? We'll get, what is a minus b whole square? A square, d square whole square is d power 4 plus b square, 4d whole square is 16d square minus 2ab. What is the 2ab? 2 into d square into 4d is nothing but 8d cube minus and so on of x square, of x square. Now we are having so many number of terms here. We are having so many number of terms here where we are having 1 multiply with x square, this term multiply with x square, this term also multiply with x square, this term also multiply with x square, this term multiply with x square, this term also multiply with x square. So that we have to multiply generally, but still I'm going to write direct step. 1 into x square, how much will get it? How much will get it? X square is the first term minus 1 by 3 into, what is the next term? D square of x square. What is the d square of x square? Already we did it in the rough work. What is the d square of x square value? Is 2. Just we'll write 2 plus 4 by 3 into d of x square. What is the d of x square? 2x. Already we did it in the rough work. Plus 1 by 9 into, what is the d power 4 of x square? 0 plus 16 into, what is the d square of x square? Is 2 minus 8 into d cube of x square is 0. So substituting 0. So we have to go for next terms. All the remaining terms will be zeros only. No problem at all. I'll tell you what is the reason. Okay. So you can put and so on, or no need to mention and so on. All the remaining terms will be zeros only. Plus 0, plus 0, plus 0 only. I'll tell you why. Okay. Wait for 1 or 2 minutes. So we'll get it. Simply 1 by 3 into, what's the first term? X square minus 2 by 3 plus 8 by 3x plus 16 2s are 32 by 9. So finally yp is equals to x square by 2. First I am writing the highest power of x. What is the second next power of x is 1. So plus 8 by 9x plus, here I am taking 32 by 2 minus 2 by 3. So what is LCM here? We'll get it 6. Numerator will be 32 3s are. How much will get it? 96 minus 4. So how much will get? 92 by 6. This 92 by 6 we have to multiply with 1 by 3. So it's going to become 92 by 18. If you want, you can do simplification. This is YP. So we got
x square by 3.
Oh, sorry, it is x square by 3. Thank you. Okay, so we got YP. Taking it as equation number 4. Okay, so what is our next step? Substitute 3 and 4 in equation number 2. In equation number 2, then we'll get y equals to yc plus yp. Sorry, y equals to yc plus yp. Then we'll get y equals to yc is, I think, c1 e power x plus c2 e power 3x plus yp is x square by 3 plus 8 by 9x plus 92 by 18. If you do simplification, you write whatever the simplified value. Hence, this is a general solution of given differential equation. This is a process of type 3.
Sir, it is 32 by 9 now.
Which one?
8 by 9.
Okay, let me check. Yes. Sorry. It is no. It is 8 by 3x. It is 8 by 3x. Check here. It is 8 by 3x multiplied with 1 by 3, so 8 by 9x. Okay, 2 more minutes here. One important point. If you did not understand the next 2 or 3 minutes, then forget about it. Don't worry about it. Okay, so here, now, you observe here, in this x term, what is the least power of d? What is the least power of d? Is 1. Is 1. I am writing with red color. 1. Okay. Whenever whole power 1 is there, 1 whole power 1 is 1 only. Okay. Next, in the second term expansion, what we'll get? What is the least power of d inside the brackets? 1. Whole square. If we do whole square, then what is the least power of d in that expansion? 2 only. If you want, you can check here. We made it. What is the least power of d? We got 2 only. But same manner, what is the next term? We'll get it. D square minus 4d by 3 whole cube. Okay. If you do the, whole cube. If we do the simplification, what is the least power of d? It is a minus b whole cube formula. Then 3 only will get. But here, the third derivative itself 0. If, what is the use of going to take next term? If you want, you can go for the next term, but still you will get 0. You go for 10 terms, you will get all the terms zeros other than from the next term onwards. Because of least power of itself 3. Okay, 1 whole power 1 is there. 1 1s are 1. 1 1s are 1 2s are 2. 1 3s are 3. 1 4s are 4, like that. But the derivative is existing only up to second derivative. Only because of that reason, we are taking up to whole power 2 only. This is first one point. And one more point. Sir, why should I have to take 3 common? Why can't I take why can't I write a denominator like this? 1 plus d square minus 4d plus 2. Yes or no? Okay, can we write like this? Yes, we can write like this. Of x square. We can write like this, but this is not acceptable. Why? I'll tell you. The reason just now I mentioned, up to which derivative it is existing? Derivative of x square is existing, second derivative. From the third derivative onwards, all are zeros. But now, if you take this is as our function, in this, better, okay, in this, what is the least power of d? 0. That means constant term is there. So d power 0. So if the least power is 0, 0 power 1 is 0 power 1 is there. 0 into 1 is 0. Next, least power is 0. 0 into 2 is 0. Like that, how many number of terms will get? You take 100 terms or 1000 terms or 1 lakh terms, we'll get all the terms zeros. Power only. That means constant term will exist in each and every term. Like that, if you take 1 crore terms also, constant terms will get it. All that constant terms, can we add it? No, not possible. Because we don't know how many number of terms are existing. So because of that reason, don't go like this. మీరు అడగచ్చు, సార్ నేను ఈ 3ని 1+2గా రాస్తాను, అప్పుడు 1+5 of D గా అవుతుందా? No, you should not take like that. So because of that reason, what is the important point I mentioned? In the denominator f of d function, you please take the total term which is having the least power of d. +3 ఉంది ఇక్కడ, +3 కామన్ తీసుకోండి. ఒకవేళ -3 ఉంటే ఏం తీయాలి? -3 కామన్ తీసుకోండి. అప్పుడు ఏమవుతుంది? ఇక్కడ -3 వస్తుంది. And here you will get -3. Okay, and this will become as ikkada chudandi, you can see here, this will become as 1 minus d square minus 4d by 3 whole power minus 1. It is in the form of 1 minus x whole power minus 1. Clear? So yes, this is our problem. Now if we observe the right hand side part, it looks like in the form of polynomial in functions of x variable. But previous problem we discussed is x power 2 or x power 3 or x power 1 like that. But here it is a polynomial in functions of x variables. So given DE is d square plus d minus 2 of y is equals to, sorry, minus 2 of y is equals to 1 plus x minus x square. I'm taking it as it is. Okay, so this is our equation number 1. What is the general solution of this differential equation? Y equals to yc plus yp is the general solution, taking as equation number 2. Okay, but we need to find yc and yp. So finding yc, while finding yc, we have to consider auxiliary equation. Auxiliary equation. What is auxiliary equation? F of m equals to 0. F of m equals to 0. What is that f of m here? M square plus m minus 2 equals to 0. Then can we find the roots for this? So the product of two values is -2 and their sum is +1. Is there any possibility? Check it. I'm taking +2 and -1. What is the product of these two values? Is -2. What is the sum of these two values? 2 plus -1 is +1. Getting it? So because of that reason, I'm going to express m as +2m minus m minus 2 equals to 0. That implies m taking common from the first two terms will get m +2, and taking minus common from the last two terms will get m +2.
1 minus 2.
Then 1 and -2, m +2 into m minus 1 will get is equals to 0. That implies m is equals to 1 and -2. What about these two roots? Are the real roots or complex roots or surds? Real roots. Real roots. And both the roots are different roots. Therefore, yc will be yc, complementary solution yc is equals to c1 into e power m1x, m1 is 1x, plus c2 into e power m2, m2 is -2x. Taking it as equation number 3. Now going to take a finding yp. So this is a new point for you, because anyhow we discussed one problem, but still going to get a new point in this. Yp is equals to, what is the actual formula? 1 by f of d of q of x. But here our q of x is, what is our q of x? 1 plus x minus x square. Then how we can write this? You take it as polynomial only. Don't write in any manner. Okay, going to write, going to take like that only. Okay, now going to take here 1 yp is equals to 1 by d square plus d minus 2 of q of x. Q of x is 1 plus x minus x square. Now, what we discussed in the previous case, from the denominator part, what we have to take common? Least power of d. What is the power of d in the first term? 2. In the power of d in the second term? 1. What is the power of d in the third term? 0. So, what is the least power of d term? Is 0, which is minus 2. So, including the sign we have to take common. That is important. Including the sign we have to take common is equals to 1 by. So, minus 2 we are taking common. Then we are going to get the denominator part will be d square plus d by minus 2 plus 1 of 1 plus x minus x square. Now going to write one more step, 1 minus 1 by 2 into 1 by, sorry, one second. So we are going to get 1 by 1 minus d square plus d whole by 2. So this is our phi of x form in our procedure of 1 plus x minus x square. Now we have to take this one to numerator part. It's going to become as minus 1 by 2 into 1 minus d square plus d by 2 whole power minus 1 of 1 plus x minus x square minus x square, like this. Now how many number of terms we have to expand? What is the expansion of 1 minus x whole power minus 1? 1 plus x square plus x cube by 3 plus 1 plus x square plus x cube plus x power 4 and so on. But how many number of terms we have to do the expansion? That is important point. For that we have to take our rough work. Now differentiation of 1 plus x minus x square. What is this value we are going to get? Differentiation of 1 is 0, differentiation of x is 1, minus differentiation of x square is 2x. So first derivative will be 1 minus 2x. What is the second derivative of the same? Again differentiated 1 minus 2x with respect to x. We get 0 minus 2. What is the third derivative of the same function? Will be 0, because we have to differentiate again the second derivative value. The fourth derivative will be again 0. So it goes and so on, all the values will be zeros. So as I mentioned, we have to continue up to power 2. Second derivative is existing, up to power 2 we can take it. So now going to write our expansion. That implies yp is equals to minus 1 by 2 of 1 plus x. X is d square plus d by 2 plus x square d square plus d by 2 whole square plus, what is the next term? We have to take, or we have to stop here itself? We have to continue with the more number of terms, or we have to stop with this? Yes, we have to stop with this, because I mentioned here up to second derivative existing, so up to power 2 only we have to continue. But you mentioned plus and so on of 1 plus x minus x square. Now we have to do the simplification inside the brackets. Okay, so while we do the simplification, minus 1 by 2 will be same. Okay, of 1 plus 1 by 2 into d square plus 1 by 2 into d plus 1 by 2 square is nothing but 4 of d square plus d whole square. It is in the form of a plus b whole square. What is a square value? D square whole square is d power 4 plus b square. D whole square. So d square plus 2ab. 2 into a value is d square, b value is d. So if we multi a into b becomes as d cube plus and so on of 1 plus x minus x square. Okay, now each and every term we have to multiply with 1 plus x minus x square. It is not multiplication, but we have to call it as we have to apply the differentiation with each and every term. That means I'll write 1 of 1, it is not differential term, so 1 into 1 plus x plus 1 plus x minus x square plus 1 by 2 into d square of 1 plus x minus x square plus 1 by 2 into d of 1 plus x minus x square. Like that we have to continue. But here if we write like that, it will take a lot of space, it will consume a lot of space and will get some confusion. So that I'm writing directly minus 1 by 2 of, what is that? 1 into 1 plus x minus x square. So it will become 1 plus x minus x square. This is only first term. Plus 1 by 2 into, here what we discussed, d square of 1 plus x square. What is the d square of 1 plus x square? We discussed already in the rough work. It is minus 2. So going to write minus 2 plus 1 by 2 into d of, what is the d of 1 plus x 1 plus x minus x square? We got 1 minus 2x. In the rough work we did it. So same manner I'm going to write 1 minus 2x plus 1 by 4 into d power 4 of, what is the d power 4 of 1 plus x minus x square value? 0. Plus d square of 1 plus x minus x square value is minus 2 plus 2 into d cube of 1 plus x minus x square value is 0. So plus all the remaining terms become zeros only. You no need to mention and so on. You can mention, no problem, but you must mention and all the remaining values will be zeros, like that. Now doing the simplification, I'll tell you why we will get zeros. Already I discussed in at the time of previous problem, but still I'll discuss again after completion of the total problem. 1 plus x minus x square minus, okay, 2 into 2 gets cancelled, we'll get minus 1 plus 1 by 2 minus 2x by 2 becomes as minus x plus 1 by 4 into minus 2, it becomes minus 1 by 2. So any other terms, all the remaining terms are zeros. So now going to take highest power of x is 2, so minus x square. Here we are having here plus x minus x gets cancels. Okay, what is the remaining terms we are going to get here? What is the remaining terms we are going to get here? Same manner, you observe one more point. Here it is. Here it is plus 1. Okay, I'm underlining with red color. It is minus 1. So same manner, here it is plus 1 by 2. Here it is minus 1 by 2. These things gets cancelled. So what we are going to get finally? We are going to get only simply minus x square, nothing else. Okay, so if we do the simplification, then what we are going to get? Yp is equals to simply x square by 2 is the answer. Okay, so this is equation number 4. What is equation number 4? After getting equation number 4, substitute 3 and 4 in equation number 2. Okay, therefore substitute equations 3 and 4 in equation number 2. Therefore, we are going to get y equals to yc plus yp. That implies y is equals to yc is c1 into e power x plus c2 into e power minus 2x plus x squared by 2. This is our general solution of the given differential equation. Is general solution of given DE. But if you want the clear explanation, why should we have to take up to of order 2 only? Further, I am explaining here. If we take in this x, what is the least power of D is equals to 1. The least power of D is 1. Okay, so here it is also 1, here it is also 1. So 1 power 1, 1 into 1, multiply it 1. 1 into 2, whole power is 2. So 2. Next term, what we'll get? Whole power 3. Nothing but 1 into 3 is 3, 4, 5, and so on. These are the least powers of D in each and every term of this expansion. 1 plus x square plus x cube plus x power 4 and so on in that expansion. But already we know that up to second derivative only, it is existing the differentiation. Remaining all the derivatives becomes zeros. In the next term, which we did not write, the least power of D itself 3. If least power of D itself 3, but that value is 0. But we know that value is 0. We know the third derivative value is 0. So why should we have to take the next term? Even if we take the least power of itself 3, all the remaining terms will be more than 3. Then all the terms become 0 because of in the rough work we discussed. So because of that reason, I am not taking the power 3, power 4, power 4 like that. Is it clear to everybody? One more important point is, for example, you may think like 1 can be written as e power 0x, okay, plus x minus x square like that. Then the first term is type 1, second term is type 3, third term is type 3. So if we do like that, then it will be a problem for us, because if you check here, only for one term expansion, that means one time that is applying only type 3 means this much length we got. That means for the second term, we'll get again this much. For the third term, again we'll get same manner. But for the first term, we have to again apply type 1. So you may feel difficulty while you are applying like this. So treat it as a polynomial only. That's enough. Okay. So any doubts, then you can ask. Now, if no one is asking any doubt, then I'll go with the one more point here, that it is problem number I think 5. Solve. This is the last problem I'm going to discuss on this. If you require, I'll explain one more also. D cube plus 2d square d cube. Okay, I'm taking like this, not this one. D cube minus d square minus 6d of y is equals to d cube minus d square minus 6d of y is equals to 1 plus x square or x square plus 1. This is the thing they are giving to us. So here, starting the solution, given D is d cube minus d square minus 6d of y is equals to x square plus 1. What is this? It is a non-homogeneous third order linear differential equation with constant coefficients. So what is the general solution? Then its general solution is y equals to yc plus yp. This is our procedure. Now finding yc. Finding yc. For finding yc, we need to consider auxiliary equation. Consider auxiliary equation. Consider auxiliary equation. F of m equals to 0. Auxiliary equation, f of m equals to 0. If we take this, what is f of m? We are going to get m cube minus m square minus 6m is equals to 0. With this, can I take m common from all the terms? Then we'll get m square minus m minus 6 is equals to 0. So here we can identify one root is m equals to 0. Here we can identify that m is equals to 0. So whenever you are getting a m value, not all the m values at a time, but in that case, what you people will do is, you please make it in the box, keep it in the box. Why? The reason is, I'll tell you. Okay, now I'll tell you after some time. Now I'm going to take a m square minus m minus 6 equals to 0. Now, if we take this, writing this is as a polynomial, how we can write product of two values is minus 6 and their sum is minus 1. How we can write it? 3 2s are. Okay, m square minus 3m plus 2m minus 6 is equals to 0. Like this we'll get it. Like this we'll get it. Okay, now writing or taking m common from the first two terms, m minus 3 plus 2 common from the next two terms, last two terms, m minus 3 equals to 0. Now we are going to get m minus 3 we can take common, then we'll get it m plus 2. 1 second, students. What I am saying, if the given differential equation, what is the order of the differential equation is 3, then are we going to get 3 roots or not? Then concentrate on writing yc. Yc is equals to c1 into e power m1x. What is m1? 0. So e power 0x plus c2 into e power minus 2x, that is m2, plus c3 into e power m3x. m3 value is 3x. Taking this as equation number 3. Okay, equation number 3. Now we need to find yp. We need to find yp. Finding yp. Finding yp. So we have to take yp is equals to 1 by f of d of q of x. What is f of d? D cube minus d square minus 6d of q of x. Q of x is 1 plus x square or x square plus 1. X square plus 1. Okay, so in the denominator we are having the least power of d is 1. So what is the total term? Minus 60. The total minus 6d we have to take common in the denominator. The total minus 60 we have to take common. So if we take, there is a common, then we'll get yp is equals to 1 by minus 6d of we are taking d common, then what we can get? Numerator. Okay, this thing becomes d square minus d by 6 minus 6. Okay, plus 1. Am I correct? Are you understanding why I am writing like this? Multiplied with okay, d we have taken common, so we'll get d square minus d only, this part. Minus 6 I am writing at the denominator. Then I'm going to write this as minus 1 by 6d of 1 by 1 minus d square minus d by 6. This is a separate term. So now it is in the form of 1 minus 5 of d. 1 minus 5 of d. So writing it is in the form of a numerator. When we write it in the numerator, what is going to become minus 1 by 6d? It will be same. This is very important. We are going to get a one more case here that you are going to learn one more point in this problem that you will understand in the next case. 1 minus d square minus d minus 6 whole power minus 1 of x square plus 1. Now, if we observe the braces, it's like 1 minus x whole power minus 1 expansion. So now going to expand it, minus 1 by 6d, I'm writing as it is, of going to get 1 plus x d square minus d by 6 plus, I have to go for one more term or not? Next term, can I go or not? We need to go for whole square also? Yes or no? We need to go for whole cube term? Yes or no? For that, what I mentioned,
No,
we
sir.
have to do the rough work. We have to do the rough work.
Only
So d of x square plus 1 is 2x. D square of x square plus 1 is 2. And find it. These are the values, because these are the values we required for our in our next steps of the problem. D cube value is 0. D power 4 value is 0, and so on. But in this, up to what extent the derivative is existing? Up to second derivative. So because of that second derivative, up to second derivative it is existing, so we have to take only up to whole power 2 only, and so on, of x square plus 1, x square plus 1. Now we have to do one more step, a little bit simplification. Minus 1 by 6d of 1 plus 1 by 6 into d square minus 1 by 6 into d plus 1 by 36 into, how it looks like, d square minus d whole square, that is a minus b whole square. A square, that's a d square whole square is d power 4 plus b square d whole square is d square minus 2ab is 2d cube plus, and so on, of x square plus 1, x square plus 1. Now I'm going to multiply each and every term with the x square plus 1. That means 1 by 6 of 6 into d square of x square plus 1 minus 1 by 6 into d of x square plus 1, like that we are going to write. But still, instead of writing that, sorry, it is minus 1 by 6d of first I'm going to multiply with 1 with x square plus 1. If we multiply 1 with x square plus 1, we will get x square plus 1 plus 1 by 6 into, what is the d square of x square plus 1? 2. That already we have written in the form, minus 1 by 6 into d of x square plus 1 is 2x plus 1 by 36 into d power 4 value is 0 minus do d square value, d square of x square plus 1 is 2 minus 2 into d cube of x square plus 1 is 0. So what about the remaining terms? We'll get zeros only. No need to write but still you can mention if you want, and so on. So finally what we are going to get, minus 1 by 60 of x square plus 1 plus 2 by 6 is 1 by 3 minus x by 3 minus 1 by 18. This is the thing. Now all the remaining terms will be zeros. Now I'm going to write only the things minus 1 by 6 into. What about 1 by d? Anybody can respond? What about 1 by d? Thank you. So here I made a mistake. It is a d square. Here it is d square. Coefficient is plus. Okay. So, but here I have written minus 2. So that is a mistake I made here. And here it will be plus 2 by 36. So it is plus 1 by 18. Thank you. Now here I am writing 1 by d as integration of x square minus x by 3. Now 1 plus 1 by 3 plus 1 by 18. LCM is 18. Numerator will be 18 plus 6 plus 1. Then we'll get 18 plus 7 is 25 by 18. Okay. So we'll get plus 25 by 18. We are taking here integration. 1 by d is nothing but integration. So we have to take as dx. Now, this is an important point. Till now in the previous 2 or 3 problems or any problem you did not get like this. Okay. So minus 1 by 6 into integration of x square is x cube by 3 minus 1 by 3 into integration of x is x square by 2 plus 25 by 18 is a constant. Integration of 1 into dx is x. So this is our yp. This is our yp. Now, you know what is the next step of our procedure? Substitute equations 3 and 4 in equation number 2. Therefore, y equals to, substitute 3 and 4 in equation 2. That implies y equals to yc plus yp, implies y is equals to yc is a c1 into e power 0x. I'm not writing that because it is nothing but 1 only, plus c2 into e power, I think minus 2 and 3, minus 2x plus c3 into e power 3x plus yp. Yp is nothing but minus 1 by 6 into, writing as it is, x cube by 3 minus x square by 6 plus 25 by 18 into x. So this is the general solution of the given differential equation. Here, this is a given problem. Solve d cube plus 2d square plus d of y is equals to e power 2x plus sine 2x of x square plus x. Now, what is the general solution here? We'll get general solution is y equals to yc plus yp as usual, because given differential equation 1 is a non-homogeneous linear differential equation with constant coefficients. Now we need to find yc. For finding yc, what we need to consider? Auxiliary equation. Consider auxiliary equation. Consider auxiliary equation. F of m equals to 0. What is f of m? First of all, we need to know f of d. What is f of d? D cube plus 2d square plus d. Now f of m will become m cube plus 2m square plus m is equals to 0. Now what we can take common? We can take m common. We need to find, we need to solve this equation in terms of m, and we need to find the values of m. So m square plus 2m plus 1 equals to 0. Now here, what are the roots we can identify. M is equals to 0 is one root. Whenever you are getting a root, immediately put it in a box. I'll tell you why. And what is the second equation? M square plus 2m plus 1 equals to 0. But if you observe, we can write it as a in the form of a plus b whole square, that is m plus 1 whole square. What is a m plus 1 whole square formula? M square plus 1 square is 1 plus 2ab is 2m into 1 is 2m. So what are the values of m? Will get it here, minus 1 comma minus 1. So finally m is equals to 0 and m equals to minus 1 comma minus 1. Why I'm saying you to put here m is equals to 0, wherever the value you are getting m value, then put it in the box. Then while you are going to write the complementary solution yc, what are the m values? Check it. If you keep it in the box, then you can identify that it is also a root. But if you are not keeping this one in the box, which one? If you are not keeping this one in the box, then you will forget. Finally, you will feel m is equals to minus 1 and minus 1 only. But always try to remember or recall how many m values we got. What is the degree? What is the order of the differential equation? Order of the differential equation is 3. We got 3 m values. So finally, we'll get yc is equals to complementary solution. Yc is equals to c1 into e power m1x. What is m1 value? 0. First value is 0. 0x plus m2 and m3 values both are same. So repeated roots. So what we'll get it? c2 plus c3x into e power minus 1x is simply e power minus x. So taking it as a equation number 3, got yc. Now we need to find yp. We need to find yp. So finding yp, I did not mention any heading for yc because you are familiar with finding yc and yp. But okay, now here, what is the formula of yp? Yp is equals to 1 by f of d of q of x. Q of x. But here, what is q of x? Yp is equals to, I'm writing 1 by f of d of q of x. What is q of x is given? E power 2x plus sine 2x plus x square plus x. Now splitting it into 3 parts. So how we are going to get 1 by, what is f of d? D cube plus 2d square plus d, I think. Let me check. Yes, it is correct only. So what is the first term is going to become? E power 2x plus, what is the second term is going to become? 1 by d cube plus 2d square plus d of sine 2x is the second term, plus what is the third term is going to become? 1 by d cube plus 2d square plus d of x square plus x. Now if we observe, there are 3 terms. What is the first term? What we have to apply? First term, type 1. What we have to apply in the second term? Type 2. What we have to apply in the third term? Type 3. Because q of x is equals to e power x in the first term, q of x equals to sine 2x in the second term, q of x equals to x square plus x is in the third term. Okay, so I just explained, I think earlier, we can treat it as yp1, yp2, yp3 like that. For that purpose, I'm taking yp1 plus yp2 plus yp3, or particular integration 1, particular integration 2, particular integration 3, and take it as equation number 4. Now we need to find each and every term of equation number 4. So what is the first term of equation number 4? Yp1. What is yp1? 1 by d cube plus 2d square plus d of e power 2x. What we have to substitute according to the type 1? With reference to the type 1, what we have to substitute in the denominator in place of d? Put d is equals to how much? 2. But m is equals to 2 is a root. Yes or no? Check it. M is equals to 2 is a root here. No, it is not a root. 0 and minus 1 are only roots. So Without thinking anything, we can substitute it here. Put d is equals to, put d equals to 2 in denominator. Now it's going to become as 1 by 2 cube plus 2 into 2 square plus 2 of e power 2x is equals to 1 by 2 cube is 8 plus 2 into 2 square is 4. 8 plus 8 is 16. 16 plus 2 is 18. 1 by 18 e power 2x. This is just yp1. Same manner we have to go for finding yp2. yp2. What is yp2? 1 by d cube plus 2d square plus d of sine 2x. According to type 2, what we have to substitute? What is the procedure of type 2 here? Put d square equals to minus a square. What is the value of a? 2. Minus 2 square is minus 4. So when we substitute d square is equals to minus 4, what about d cube? Find out d cube also. D cube equals to minus 4 into d is minus 4d, obviously. Now substituting these other things in our problem, 1 by, what is the d cube value? Minus 4d plus 2 into d square value is minus 4 plus d of sine 2x. Now what is going to become denominator part? Anybody can say? Minus 3d minus 8 of sine 2x. Now can I do rationalization in the denominator? I am taking minus 1 common. Then what is going to become? 3d plus 8. We have to do rationalization. For rationalization, with which one we have to multiply and divide with? 3d minus 8, multiplying and also dividing. Then it's going to become minus 1 in the numerator. I'll take inside numerator part. Then it's going to become as 8 minus 3d is the numerator by denominator will become as a plus b, that is 3d plus 8 into 3d minus 8. A plus b into a minus b form a square minus b square. 3d whole square minus b square is 8 square of sine 2x. Now if we continue with the same process, what is going to become? 8 minus 3d by denominator will become 9d square minus 64. What is the d square we have to substitute here in the denominator? According to type 2, put d square is equals to 2 square. Put d square equals to minus 2 square, which is nothing but minus 4 in denominator. No other option. Okay, so when we substitute this, we are going to get the denominator part will become as, numerator will be same, 8 minus 3d by 9 into, okay, I'll do one thing here. I'm substituting in the denominator, sorry. So what we are getting here? We are getting here is equals to, I'm writing only 1 by 9 into d square. In place of d square, substituting minus 4 minus 64. Now multiplying each and every term of numerator part. What is the each and every term? Is nothing but 8 is one term minus 3d is one term. So multiplying both the terms with sine 2x. So it's going to become 8 into sine 2x minus 3 into d of sine 2x. d of sine 2x. Now, going to get the denominator is 9 4s are 36. Minus 36 minus 64 is minus 100 is denominator part. And the numerator part will be 8 sin x, 8 sin x minus, sorry, 8 sin 2x minus 3 into, what's the differentiation of sine function? Cos. What's the differentiation of sine x plus b? Cos of a, oh sorry, a into cos of ax plus b. What is the a value will be here? Here it is 2. So 3 2s are 6. So we are going to get here it is 6 times of what we are going to get? Cos of 2x. This is our just yp2. If you want, we can take this minus 2 inside the brackets. It will become as 6 cos 2x minus 8 sin 2x. Now we have to go for finding yp3. What is our yp3? yp3 equals to 1 by f of d, d cube plus 2d square plus d of what is q of x in yp3? X square plus x. Now we need to take which one common in the denominator? What we have to take common in the denominator? Any response? So if we for expanding this 1 plus x whole power minus 1 expansion, there are infinite number of terms. For that, up to which power of x we have to continue. For that, going to find the rough work. Differentiation of x square plus x is 2x plus 1. Second derivative is 2, and the third derivative is 0. Fourth derivative is also 0. And continuing on so on, the higher order derivatives will be equals to 0. So now after we are expanding 1 plus x, okay, 1 plus x whole power minus 1, 1 minus x plus x square minus x cube and so on, then we have to stop up to the second power of this is up to 2. Now here I'm going to do one more step. 1 by d of 1 minus d square minus into plus minus 2d plus, putting brackets like this, these in the form of a plus b whole square. A square, that is d square whole square is d power 4 plus b square. B square is 2d whole square is 4d square plus 2ab. 2 into a is d square, b is 2d. Then we are going to get 4d cube minus and so on of the same function x square plus x. Now we have to multiply all the terms with the x square plus x. If we multiply with all the terms with x square plus x, what it's going to become? Going to get like this is equals to 1 by d of the first term will be 1 into x square plus x is x square plus x minus d square of x square plus x is 2. That we have find just now in the rough work. D of x square plus x is 2x plus 1 plus d power 4 of x square plus x is 0 plus 4 into d square of x square plus x is 2 plus 4 into d cube of x square plus x is 0. Now if we go for the next terms also are going to get as zeros only. So 1 by d of, now I am writing the highest term of x square. What is the next? X terms, x minus 4x only. So what we'll get finally? Minus x minus 4x is minus 3x. Next, we are going to get here. Now we have to take only the terms which do not contain x. So for that, observe here it is minus 2. It is a minus 2 into plus 1 is minus 2. Minus 2 is minus 4. Minus 4 plus 8 is how much? Plus 4. So we have to take that plus 4. Here it is plus 4. This is our yp. Is it yp? No, not yet completed. We are having 1 by d. Denominator should not have any d variable. So 1 by d can be written as integration. Integration of x square minus 3x plus 4 of dx. Now integration of x square is x cubed by 3 minus 3 into integration of x dx is x square by 2 plus 4 into integration of 1 into dx is x. So what we got finally? yp3 only we got. Now we have to substitute all these things in equation number 2. So equation 2 becomes, what is equation number 2? Y equals to yc plus yp. What is I'm writing same yc. What is yp1? Yp we mentioned as yp1 plus yp2 plus yp3. Now y is equals to yc is c1 into e power 0x is c1 only, plus c2 plus c3x into e power minus x, plus, so this is our yc. Check. What is the yc we got? C1 into e power 0x, nothing but 1 only, c1 plus c2 plus c3x into e power minus x. Product e power minus x is exist only for c2 plus c3x. Now what is the yp1 we got? Yp1 is e power 2x by 18, e power 2x by 18 plus e power 2x by 18 plus yp2 is minus 1 by 100 into 8 sine 2x minus 6 cos 2x. So I am writing here it is minus 1 by 100 into, anybody can remember, 8 sine 2x minus 6 cos 2x plus yp3. Yp3 just now we got x cubed by 3 minus 3 by 2 x square plus 4x. So we got the solution of the given differential equation. This is by using in a single problem. All the three methods are there. yp1, yp2, yp3 is this one is a general solution of given D. Okay, this is the solution. So same manner you can do any type of problem using type 3.